This is the Internet Routing and Traffic Security track, a view from Cloud and CDN Providers. Our first presentation is entitled Decentralized Security of a Globally Distributed System, Challenges and Opportunities. Since 2001, Andrei Robushevsky has spoken from the NANOG stage 5 times, most recently providing a lightning talk about the next chapter in MANRS in 2019. With that, we'd like to welcome Andrei to the stage.
Hi, thank you. So 8 years ago, almost 8 years ago, an initiative called Mutually Agreed Norms for Routing Security was started. And today, together with you, I would like to look back at challenges and opportunities we've seen on this way in all these 8 years, and maybe distill some of the lessons that we can apply to a bigger challenge that were very common in the internet, which is a challenge of securing a decentralized and distributed system like the internet is. Now, 8 years of routing security is only a fragment in more than 25 years of our effort, collective effort, in trying to secure a routing system. Well, 25 years is a long time, especially on the internet scale. So why is routing security so hard? I think a simple answer is it's economics. Because while the incentive for the global routing system as a whole, a business case, is significant, the business case for individual networks is often not so much. Because, well, partly because the security of individual network, it depends on actions or inactions of other operators. And therefore, individual network can do only so much to secure their own. That means that to secure routing, we need a concerted action with as little as possible for free riding, which is an enormously difficult task. So, well, in some of those cases, which is commonly known as collective action problem, regulation was called to save us, but in this particular case it won't work, partly because, or mainly because, it's a global problem, and securing this in one jurisdiction will not allow security of routing system. Norms, or developing norms, is a much more promising approach, but for this they need to be widely accepted, non-disputed, not exactly low, so majority can join, but not too low that it doesn't make any difference. And what's very important is they should be visible and measurable. I mean, we should understand which networks, well, I'm translating this to network environment, which networks abide by those norms and which are not. So MANRS, which again stands for Mutually Agreed Norms for Routing Security, it's exactly built on two premises. So one, it creates a baseline, which is called in MANRS actions, requirements, controls that networks need to implement. That is undisputed, and it leads to changes in the routing system security. And the second, it builds a community of network operators that stand by, that implement actually those norms, that demonstrate they implement those controls. And they support by peer pressure, by their presence, by their voice, this baseline. Now, the initiative was started with network operators coming together and developing those requirements. There are 4 requirements at that time, and we call that Network Operators Program. But immediately after the launch of this program, we had a challenge how to scale this initiative up. It was started with 9 operators, but as you know, there are more than 70,000 autonomous systems operating in the routing system. So how to bridge this huge gap? And we're looking for other partners, for partners that can help us to create sort of a snowball effect in MANRS. And the next partner that came to mind and was willing to partner with MANRS were internet exchange points. And not surprisingly, because internet exchange points, they're sort of locus of community activities. They have their communities with common operational objectives where such norms can be spread further. Now, that program was launched in 2018, and 2 years later, we looked at other potential partners. And other potential partners were CDN and cloud operators. So, although they're sort of edge networks and you can treat them as network operators, they're very significant edge networks. Some statistics shows that 50% of the traffic is handled by them, and a routing mistake can have very significant consequences. So CDN Cloud program was created and launched in 2020. I'll talk about this program a little bit more later in the talk. And finally, in 2021, we launched the Network Equipment Vendor Program, because without equipment that can support those controls, you can't achieve routing security. Now, actions for each of the problems are different. Those requirements and controls are tailored to particular entity, particular group of entities, depending on their position and their role in internet routing. But there are some common themes. For instance, for most of them, filtering is one of the important actions, which basically says, do not emit and propagate incorrect routing announcements. Coordination is another common action, which says you have to be open to coordinate. And as you know, many of the incidents there, if not prevented but mitigated quickly by this ability to coordinate across borders, across networks. As you know, routing security depends on correctness, availability of external sources, RPKI and IRR repositories. And it's very important that information registered there is correct and up to date. And maintenance of this information is another action. But also there is another action which is not technical, which is promoting MANRS. If you are network operators, it's your responsibility to promote this among your customers. If you're an IXP, promote this among peers. If you're a CDN, promote this among your peering partners. So why join MANRS? And the sort of common messages were, well, first of all, by joining MANRS, by implementing those controls, you improve your own security posture. And that's a benefit, because you don't want, for instance, that your customer becomes your transit provider and creates an outage for you. Also, more and more, this baseline becomes a norm. We see this. I mean, it becomes less and less acceptable to sort of be sloppy, to create those mistakes, and not to fix them quickly. And another thing we sort of were saying, use MANRS as a competitive differentiator. Now, that part is, I don't think it's strong enough, and I will talk about this again a bit later, a few slides away. We hope that it can be used, but I'm not sure it's used at the moment as a real commercial differentiator. So I was talking about measurements. So if you talk about norms, you should be able to measure. You should be transparent. And for this, we created a tool called MANRS Observatory. And MANRS Observatory, its role to basically monitor and present the state of MANRS conformance. Right? It's a conformance tool of MANRS participants. But because we're using a measurement framework based on passive measurements that do not require cooperation from other networks, we can actually measure MANRS conformance also for non-participants, for all networks on the internet. It's transparent, it uses publicly available data, it's passive, as I said, and it's evolving. So as MANRS, as controls evolve, we adjust the measurement framework as well. That's a landing page of the MANRS Observatory where you can see sort of some numbers and trends related to routing security and conformance to MANRS controls. Publicly, what we have available is those averaged scores by country, by region. But for MANRS participants, more detailed data is available, the individual scores of networks, but also detailed reports that explain why your network got that score. And some work is underway to make those scores actually publicly available. So when you go to MANRS, you can see the sort of, well, that's the declared controls, and that's how they are measured, which should improve credibility. Well, that's the progress so far. We're 8 years. The statistics are slightly outdated because we are adding numbers by day. But the graph shows the rise in network operators, and we see similar things in other groups, although those groups are smaller. Now, I tried to answer the question, what's the impact? Does MANRS have any impact? And of course, it's speculative. I mean, causality has to be proved here, but I put a few statistics on one graph, and in my opinion, that's very positive. We see that number of culprits, networks involved in an incident, it steadily decreases while the number of participants are growing. I'm cheating a little bit putting this on one slide, but still it's a nice slide. And we also see that routing information quality is improving. I cannot stress strong enough that MANRS is a collaborative effort. Internet Society, which I work for, they provide the secretarial function. We support MANRS financially and also organizationally. But the real sort of efforts, it's done by network operators, CDN providers, IXPs, and network equipment vendors that participate in MANRS. I'd like to sort of pause a little bit and talk about CDN and Cloud program, and we'll see more presentations in this session from CDN and Cloud providers, how they, their journey in routing security. But this program is interesting because after being launched, the CDN and Cloud providers came later, a few months later, well, maybe a year later, back and said, well, we can do better. We can create actions stronger. We can introduce more controls. For instance, one of the important actions in every program is filtering, ability to prevent incorrect routing announcements from propagating and appearing in the internet. And what we thought of as a group when we create this program, and by the way, I have to say it was created and developed as a community effort because a task force, a working group was created, and then the last set of actions was called for the last call for the MANRS community. So what we thought is, why are we not requiring RPKI as a priority source for validating those announcements? And while we were thinking about this, we also thought, well, and what's the priority? How you validate? Should we standardize a little bit the validation flow? And also thinking, well, I mean, route objects in the IRRs, it's a problem, but even bigger problem, IS sets, it's sometimes a mess. So should we streamline this as well? How you expand IS sets? What sort of semantics or what sort of rules should be there? And the same we expanded for global validation. While the original action didn't specify what needs to be there, we wanted to be more explicit that this information should be reflected in the IRR and RPKI systems. And where I say we, I probably took too much credit. It was the working group that created this. So another example of collaboration is the tooling. There is a GitHub with MANRS tooling, and some of them are, well, they're little open source projects that everyone is invited to contribute. Some of them are contributed by the participants of MANRS. Some of them are sponsored by Internet Society. For instance, MANRS Validator, we're working on a tool that allows automation of checking MANRS conformance in more detail. Or MANRS Lab, which can be used as training material, which is also an open source project. Or MANRS IXP validation tool, which checks how well RPKI is implemented in route server validation flow. Another facet, the third one, is self-governance. While, as I said, Internet Society's secretarial function, more and more decisions are now taken by a steering committee. I think steering committee was created 2 years ago. It's a 9-member steering committee. I don't know if any members of the MANRS steering committee are in the room. Probably not. And, well, role of steering committee, the regular meetings every 2 or 3 months. A meeting of steering committee reviewing, approving MANRS actions, but also looking at developments, advising on priorities, and so on and so forth. And by the way, in November, there is another election coming up. It's electronic. MANRS participants are allowed to nominate, to be nominated, and to vote. So if you're a MANRS participant, please stay tuned to that. Now, I would like to talk a little bit about what's next. And here we go about challenges and opportunities. So if you look at MANRS and ask, does MANRS work? And you can hear, yes, it is. It is community focused. It's based on peer pressure, and it has reputational value. I think I spoke to MANRS operators, and they feel that bearing MANRS badge, it is a sign of higher reputation, of better quality of operations. But there are a lot of areas of improvement. Our attempts to make conformance stronger or conformance rules stronger, to request more feedback, to engage and encourage more participation from the whole MANRS community, it has limitations. And we think that the core of the problem is in the how strong or how weak is the business case, because you can go only so far, you can ask only so much from a network operator, as much value they get from MANRS. And as long as just reputational value, that's what you get in return. So there is still not enough incentive to excel. So what we are working right now is we're trying to create another tier in MANRS. So MANRS as a community reputational thing is very good. It has a lot of awareness, but we are trying to distill, sort of create a more ambitious group of MANRS participants that can aspire to a higher set or more strong set of requirements. And we focus mostly on customer-provider relationship because that's where they can get the value proposition from. So if customers begin to value this quality mark, then it becomes, it's a business case that why would you join and put extra efforts into becoming a MANRS Plus member. So this work has just started, and in fact, it's open for everyone, not just MANRS participants, to develop this set. So if you're interested, please contact us. But what we are thinking of, it should go maybe beyond the initial set of requirements of MANRS and maybe beyond just routing security. I think what ultimately is a stack is traffic security, and that's what we should be looking at. It should also be better aligned what customers require from their connectivity provider, not what connectivity provider can make. So better alignment with this can improve value proposition. And another challenge that we need to overcome and discuss is how can we make audit more credible and transparent. As I said, right now we are using passive measurements, but passive measurements have limitations. There are only so much you can see from the outside about controls that are implemented in the network. Just to give you one example, on filtering side, we are measuring non-compliance. So if a network is implicated in an incident, that is an indication that controls are not implemented. But we can't say for sure that controls are implemented in particular network. So we need to look deeper, maybe without on-site audits, because that would be over the top. But how can we make it stronger? So what's next? Well, first of all, if you haven't joined MANRS, please join. It's not that difficult, and it will strengthen the effort. If you're interested in MANRS Plus developments, please get in touch with us. And even if you're not the MANRS participant, please ask your providers, are they MANRS conformant? And if not, why not? I think that brings me to the last slide of my talk. Thank you. Are there any questions?
Okay, thanks for the presentation. I was asked, is there a real-time lag between when the standards, IETF standard is formed, let's say a new security on a routing protocol, right, is formed, to a device vendor or a cloud operator actually implements it, to when you are proposing and auditing, to when it gets into the auditing tool, right, to when there's an actionable mitigation done? How much is that entire loop? The lag time between, when there's a new standard or an extension to the standard versus when it is implemented to when it's actually actionable with the auditing. So can you give us an idea of any real time? Because this is a lagging audit, right? So, but when the standards is upgraded, what is the lag in which actually there's something actionable out of it?
Thank you. Yeah, well, I think the lag is certainly not real time, and it's much more, I think it can be measured in years sometimes, because from the moment the standard is developed, it needs to be adopted by the vendors, and that needs to be sort of deployed in new equipment. And then MANRS, it's actually not the immediate implementation of standards. The MANRS requirements and controls are distilled from best current practices and standards, right? And they're actually not the best current practice. I shouldn't probably say that, but they're minimum base requirement. So lag can be significant. And MANRS actions, they also, those controls are pretty stable. We can't change them quickly, right? Because it means that people signed up for one set of requirements will need to re-sign up. And right now we don't have this kind of, annual recertification of MANRS participants. So the lag can be significant, but we think the current controls, if implemented widely, they can still make a very significant impact in routing security. I guess there are no more questions. Thank you.
No more questions. Thank you, Andre. Thank you, Andre. The second talk in this track is entitled A Multi-Pronged Approach for Securing Internet Routing. Joining us remotely today is Anis Sheikh, and he is with the global networking team at Google, where he works on software systems to support network management, cloud networking, and routing security in Google's production networks. Anis has been a longtime contributor to NANOG meetings for almost 8 years. His participation on this track marks the 4th time that Anis is presenting at NANOG. With that, we'd like to welcome Anis remotely. Thank you.
Thanks, Steve. Hopefully people can hear me okay. First, I'm really sorry not to be there in person. I was planning to be there in LA with all of you in person. That didn't quite work out in the last minute. So having to present remotely, hopefully this will work out okay. So the theme of this session is sort of a cloud provider perspective on routing and traffic security. And I'm going to try to give a little bit of perspective on how we've approached the problem at Google, using a number of different techniques, since we really found that there's no single technique that works well. I'll be presenting work that actually spans multiple teams inside of Google. I'm really proud to work with some fantastic engineers in our development teams, our SRE teams, and our operations teams. And it's really just my privilege to present the work done by many others. So let's start with a little bit of background about the network. Google runs a very large, owns and operates a very large private network to support its cloud. This picture sort of shows the customer external-facing view of how customers can deploy workloads in the cloud and also connect to our network. In particular, I'd call out the number of edge locations. It's a slight underestimate of the number of locations that that peer networks can connect to Google. And so we reach our customers and users largely through peering and also through some private connections, as I'll show in a second. So there's roughly just under 200 or so locations where we connect to other networks, which is relevant for this discussion. So a little bit more background. So when we look at Google's private WAN, it supports sort of 2 large classes of services. One is some very large user services. We have about 9 services today that have about 1 billion or more users globally. You can see the list here. And then also, this network supports traffic to and from cloud customers. So these are businesses from every industry, all different sizes, that connect to us for computing infrastructure and services. So Google, by this kind of view, looks like a stub network by the traditional definition, but we're an atypical stub network in the sense that we have a very large peering surface, thousands of networks ranging from global network providers, tier one and so on, all the way down to small regional and even consumer broadband providers. And we also have customers that connect directly to us via peering to access some specific types of services from the Google Cloud Platform. And this doesn't count sort of the private connections that we also support that don't use peering. They use private connections that we call Cloud Interconnect. So peering at Google is done via roughly 100 or so private interconnection facilities and another 90 or so public internet exchange points where we maintain a presence. So with that background, let's move to internet routing security and the disruptions that we see. I don't think I have to say much in this forum about the problems of routing security. I think Andre covered some of it well. It's certainly very impactful for us, and we pay a lot of attention to routing security because when we have disruptions caused by hijacks or leaks, it easily causes black holes, high traffic concentration, which leads to congestion or packet loss, and then even traffic redirection and potential for interception. So it's a very serious concern for us and for, I would say, all cloud and content providers. From a cloud provider perspective, we need to protect against multiple types of disruption. So on one hand, we worry about hijacks and leaks of our own routes in the internet. This impacts users and customers' ability to reach Google services. And on the other hand, we also care about routes that are advertised to us directly that may be invalid. So bogus routes that we get impact reachability back to our users, and also for cloud customers that host with us, their ability to reach their users and external services gets impacted by that. So we need to worry about both aspects of the problem and how to detect and mitigate the impact when it does happen. So we've organized our work in this space into 4 broad areas. And for the rest of the talk, I'll cover some specific details of systems that we've built in each of these spaces. But as the overview, we have route intent publishing, which is really the problem of how we make sure that Google and GCP routes are up to date at all times in public registries. So this enables other networks to validate, our routes when it comes to propagating or when they receive announcements for Google routes. And it prevents propagations of hijacks, obviously. So this helps protect connectivity, back to Google from the wider internet. The second sort of pillar here is around validation of route announcements that we receive. So we've been working over several years with our peers and customers to register the routes that they have so that we can build correct filtering. And of course, others can build filtering as well for those same networks, and then deploy those filtering systems to accept valid routes from all of our peers. And this prevents us from accepting those bogus routes and make sure that connectivity from Google and GCP is protected. The next area is really focused on visibility. So this has to do with our focus on building first-party and third-party monitoring systems that alert on hijacks that happen outside of Google's network, where we don't have direct visibility. So we use other sources and some of our own sources. This helps us to proactively reach out and mitigate when we do see problems, especially significant problems outside when we see hijacks or leaks of our routes. It does reduce the mean time to repair, but as you know, this depends often on actions taken by external networks. So there's ultimately some dependency that we have on other networks to take some action, whether it's the offending network itself or maybe an upstream provider to stop propagating or accepting some bad routes. And then finally, following along with Andre's talk, I think a big part of our focus has also been on how we collaborate to accelerate progress in this space. This is not an area that Google alone can solve, or any cloud provider really can solve. I'll be talking about this problem from the perspective of Google, but a lot of the work that we're doing here is much more generally applicable. We have been active members of the Cloud and CDN program in MANRS, and have found it a very valuable means of collaboration. It gives us an opportunity to work with other providers to align on some common ideas and solutions, even develop policies that we can sort of align on together. and also gives us just a forum to share some experience and information with other MANRS members. So it's been super useful in that regard. Okay, so let's jump into some of the specific systems we've built to implement some of this. I'll start with route intent publishing. So here, the idea is to make sure that our routes are published and maintained, most importantly, in public databases like the Internet Routing Registries as well as the RPKI. So at Google, we have multiple engineering teams that are responsible for our external announcements. So our first problem was, collecting these intent sources and consolidating them into one sort of set of intent sources from which we could build an automated pipeline that basically periodically looks for changes in those intent sources and updates our registrations. In the IRR, we use RADB for our registrations, and also in the RPKI. And we've used so far hosted RPKI services run by the different regional internet registries. Some of these RIR host RPKI services have programmatic APIs that we can take advantage of from an automation perspective. Fortunately, those are the same RIRs that also we have most of our routes in. But then we do have some that still require some manual management, which fortunately is a relatively small number of routes. So at this point, we've registered nearly all of Google and GCP routes in both RPKI and IRR. But there's a second half of this problem, which is to monitor the state of those registrations. So we do this by consulting a number of third-party data sources that indicate status of routes, in particular that will show us any route that's seen with a Google origin that looks like it may be RPKI invalid, which might indicate a gap in our registration system, maybe something we missed in our intent sources, or a change in the RPKI that we should know about. One challenge that I don't think a lot of people understand when they start down the RPKI journey with registering their routes is that the management and maintenance is as important, more important than the initial registration, right? So I think this sort of ensures that we get notified quickly when there's a problem, because if one of our routes goes invalid, of course, there's a risk that it'll get filtered, since more and more large networks are doing filtering based on RPKI and origin validation. So we have this continuous monitoring system that'll proactively detect these gaps. We've also deployed, as another means to protect the Google routes outside, this notion of peer locks, which I think has been introduced a while back in this forum by Yob and maybe others as well. So peer locks are a simple form of AS path filtering, where effectively we work with large providers to build simple AS path filters that will only accept Google originated routes from specific ASs. Typically, this would be from Google itself. And in some cases, it might be from us directly or from one of our regional transit providers, for example. So this helps mitigate propagation of large leaks. And in fact, we started looking at this technique after we suffered a pretty big impact from a large route leak back in 2018 that I'm sure people may recall. And so far, this has been fairly successful. We've implemented peer locks with about 15 large tier 1 and transit providers around the internet, and sort of work with them periodically to keep the peer lock filters up to date. Coming to route filtering, the focus here again is on validating all incoming routes that we receive at our peering edge. And here we've deployed multiple filtering mechanisms to address the different kinds of hijacks that we see. The first one is filtering based on data that's in the public internet routing registries, or IRRs. This basically builds a view of what routes a peer is expected or allowed to send to us based on the routes that it itself is registered, as well as sort of the transitive expansion of the AS sets that contain the networks behind them. So as Andre alluded to in his talk at the beginning, there's some standards that we've also worked on in how you do AS set expansion in a standard and common way to make it clear, how such allow lists are built. The challenge with IRR data, of course, is that there is high coverage, but the data can be stale, it can be invalid, it might be contradictory. So that requires some work with all of our peers to ensure that the data hygiene improves, and we've made some progress, some reasonably good progress on that. This is currently rolled out widely across most of our ISP peering sessions, and we're sort of transitioning from what we call depref mode to reject mode, where we're rejecting IRR invalid routes on many of our sessions now. The other type of filtering, of course, is route origin validation based on RPKI. This is where we're filtering on the allowed origin based on ROAs that are registered in the RPKI. Prevents a lot of different types of misconfiguration oriented hijacks. The challenge, of course, with RPKI is that the coverage is much lower. So, I think as we know, just under 40% of the IPv4 space is registered, which means a lot of the space is yet to be protected in RPKI. We do have this in pilot now with active filtering, and it's targeted for extending the rollout over the course of this year and early next year to most of our peering sessions. Just quickly, in terms of how IRR-based route filtering works, this is a pipeline that runs periodically. We collect data from roughly 25 different routing registries. We're really interested in reducing that number to those that support, only those that support authentication, for example. We also collect data from PeeringDB to get AS set information. This is collected periodically, and we build a view of the routes that each peer is allowed to announce to us. We store this in a system that we call the route intent store, and this is used to build effectively a route filter that's essentially an allow list of those routes that then gets rolled out to the network globally, on a periodic basis. So we keep the filters up to date as changes happen in the IRRs through this periodic collection, processing, and then roll out to the network. We also publish this information to our ISP portal. I'll say more about this a little bit later in the talk to help peers see the current status of their routes in terms of IRR validity. We've used two different modes for IRR filtering. We started with depref mode, where we were essentially lowering the preference of routes that appear as invalid in the IRR. And this was meant to be, after initial communications to the peers telling them that we're doing this, this has a more direct impact on traffic so that they would actually take some notice and make changes. And we work with peers on that. We've now started, as I said, transitioning to reject mode that provides better protection than simply lowering the local preference of invalid routes. There's a few issues, of course, with IRR-based filtering that we've had to deal with. Aside from the data availability and accuracy that I mentioned already, there's the issue of making sure that the filters are scaling, managing their scale on routers, and also that they're, since this is a global rollout to our peering edge, according to our production principles, this is done in a gradual and progressive way, which means that it happens over roughly a week's time. Moving on to RPKI-based filtering, our architecture looks roughly like this. It's a bit different than the traditional RPKI filtering that you may have seen. We have sort of the top half of this is a pipeline that collects data from the RPKI. We have a replicated set of relying party instances that collect data from trust anchors and RPKI repositories, and builds this into an internally developed RPKI cache that has the latest VRPs from these RP replicas. Then at the bottom, we have essentially a monitoring and validation system. So we have a globally distributed set of horizontally scaled validators that collect route information. They monitor the routes at the peering edge, in other words, as they come in through this route listener layer, and will validate the routes against the RPKI cache contents that they have. And then if they detect that a route is invalid in the RPKI, they will automatically install a filter to remove that route. So it works in a more reactive fashion. And we've had to build a couple of safety mechanisms here. One is that the RPKI cache itself sometimes runs into situations where a large amount of data disappears, let's say, from the RPKI because of a failure in the RP or some other issues with downloads. So we've built a fail static type approach here, where we'll use the last good set of cache contents and continue until that can be repaired. And we also have a mechanism to provide overrides if there's a problem in the RPKI data, where we can add a local override to the RPKI cache, very similar to other standard mechanisms using Slurm, for example. Just a little bit about how we help our peers in terms of visibility. So the peering portal that Google has maintained for a long time has been extended over the last couple of years with a lot more information about route validity. So the BGP view that we have shows a peer that appears with us, all the routes that we see and their status from an IRR and RPKI perspective. And then if there's a problem detected, there's additional details that are available that helps them troubleshoot what the problem might be. So for example, in this case, there's no route object for this particular route, or there may be an AS set object that's missing. And it'll give information about what AS set objects we're using, what route objects we're seeing. So it helps peers understand quickly how they might be able to fix their IRR data. The last sort of part of this is around the monitoring and alerting. There's not a ton to say here, except that I just wanted to mention a couple of things. One is that we use the same sort of intent sources that we use for publishing our routes in the RPKI and IRR to also populate our monitoring systems. So as I said, we have both first and third party monitoring. Some of the interesting challenges here really have to do with improving the signal to noise ratio with this sort of route monitoring. Raw alerts are pretty frequent. We've built some heuristics that make sure that an alert is, or an event rather, is both persistent and also widely observed, or widely enough observed, such that it merits raising an alert and let's say paging someone to go take a look. The mitigation, as I said before, generally requires some actions by external networks. So that does have some dependency, but it has helped us proactively detect and alert on events that we wouldn't have otherwise even known about. So I will start to wrap up with a couple of observations and experience that we've had in building these systems over the last couple of years. One is that the IRR-based filtering service drove meaningful improvements in peer data hygiene. I think this engagement with communications and then moving from sort of deep pref and then reject mode for filtering has helped improve overall IRR data hygiene. And we've seen a slow but steady improvement in the overall validity of the peer IRR data that we see. We've also adopted policies where every new session that we turn up has to have valid IRR entries, and that's helped drive some additional improvements. We did notice that we see a lot more RPKI invalid routes than what we observe in what is observed in the public routing tables. So we see, for example, some invalid routes are advertised only to us, and peers performing some forms of traffic engineering often are misaligned with their ROAS. In other words, they can't keep their ROAS up with the traffic engineering that they're doing on routes that they may send us. I would argue that RPKI registration and management is still too hard. We haven't made it easy enough for operators to do this. This is based on just our observation and the amount of churn in the valid and invalid routes that we see at our edge. There's too many different interfaces and policies that are used, for example, in hosted RPKI services today. And it requires some significant investment in automation to keep them updated. And then finally, RPKI is important, but it doesn't solve all of our problems, right? We've seen real instances, not hypothetical, of determined attackers being able to defeat OV using pass spoofing. And then I'll just end my last slide just by reemphasizing the importance of collaboration here. I think we've had some successes. I think Andre already called them out, so I won't mention them again in terms of the collaboration in the Cloud and CDN Provider program. And we are looking forward to leveraging MANRS as a continuing vehicle for collaboration with the wider industry. With that, I will stop and see if there's any questions. Thanks very much.
I'd like to provide anybody locally with an opportunity to ask questions. Are there any remote questions? No. We have somebody in the...
Hi, Ben Madison from Work Online. Maybe you could just go back to your slide on your RPKI origin validation topology. It's quite a departure from the kind of the normal RTR protocol-based approach. And whilst it makes sense, it's not clear to me what motivated the slightly more customized architecture. Are you in a position to explain a bit more about why you chose to do things that way?
One of our motivations I can say a little bit about is that RTR represents another feature on routers that we have to qualify, maintain, evolve on new platforms. And I think we're very careful about introducing new features. So in this architecture, we're able to use our existing automation that we have built over years to install filters, change configurations as needed, without introducing a new feature, a new protocol, a new entity that needs to talk directly to routers, where I think there's some we perceive as being risky as well. So this is some of the reasons why we went with a little bit different approach than the standard RTR based one.
Thank you.
Next question.
I have a few questions from remote participants. First, Doug Montgomery asks, how do you time out the filters that the listening layer injects to routers on ROV invalids?
Yeah, so the way that we're doing that is by looking at, again, feeds from routers that we see. So we can still see the routes that are being advertised to us. And then when we see the invalid routes being withdrawn or fixed, then we can remove those filters. If the RPTI contents change such that a route becomes valid that was invalid before, we also respond directly to those changes and we'll update filters accordingly.
Got time for more? Yep. Next question for Matthew Pitek. He asks, you mentioned you push updates weekly and mark invalid prefixes for dropping. Do you provide an ability for peers to request a faster update? Example, if they sign on a new large customer who wants traffic to start flowing sooner rather than having to wait a full week for Google to push out new filters.
Yeah, it's tough for us to do that because, as I said, these updates are deployed globally. So we take a lot of care with any sort of global update to our edge routers. So we can't actually do them faster. We do have other mechanisms where we can install a temporary override or bypass that would potentially address the kind of concern that such a peer would have. We have run into this with peers and we've had to explain that, please make the change, but it will take a few days for it to roll out. It doesn't always take a full week, but it can take up to that long to roll out the change.
One more question. Blake Willis asks, in terms of data hygiene, have you had success reaching the long tail of smaller providers with nasty announcements and bad IRR data, particularly in developing countries?
I don't know the distribution offhand of sort of geographically how the hygiene looks. I mean, in general, though, the smaller networks with a smaller number of routes, let's say a handful of routes that they're sending us, are relatively easier, I think, to get sorted. Where we have more persistent challenges, I think, are with medium to larger size networks where there's many routes that are invalid and they just don't seem to have an ability or a motivation to fix their routes. So I think that's where most of the struggle is. I think there is that long tail, and probably it's true that in some geos it's going to be harder than others to do, but I don't have the distribution offhand. Sorry.
Thank you, Anis. And thank you to our local and remote questions, folks asking questions. The next speaker in our track is Frederick Korsback. I'd like to introduce Frederick. He'll be presenting how AWS is helping to secure internet routing. Frederick has actually been passionate about routing security and has been part of the internet routing security community for quite some time, working to deploy MANRS over 3 ISPs. With that, Frederick.
All right, thank you very much. Hi, Nonog. My name is Fredrik Korsbeck, typically known from the European scene since I'm from Sweden. My boring corporate title is Senior Infrastructure Business Developer, but I typically go with like the BGP guy. So as everyone else here has done, we need a network primer. There we go. A map, right? so we can kind of get a context of what we're talking about here. So the AWS network consists of roughly 400 edge locations globally in the world. We have 87 availability zones, which then forms the 27 cloud regions which we are currently operating. We have thousands of routers, and we have tens of thousands of BGP sessions, and we have 100 million plus IPv4 addresses to protect, and obviously trillions of gazillions or whatever it is in IPv6 addresses, right? So that is kind of the context of what we are to talk about today. So we start with RPKI. We can look at where are we today. I have a blog post which I wrote a year ago for the kind of the full context for the dive deep stuff. But the short ones are that we are dropping RPKI invalids in 100% of our internet border in over 400 of our global POPs since December 2020. So that's 2 years in the makings, I would say. We have signed more than 99% of our IP space today, and we have like a fully automatic ROA renewal machine, or maybe an IP vending machine, if you may. Like every internal team that wants to produce anything on AWS, they need IP addresses, right? And they go to the vending machine of sort, and we take care of the rest for them, right? Like we do the IRR registrations, we do the RPKI ROA registrations. You have probably seen that we have a lot of rolling over with these certificates over each other, so that it's like a live and kicking system. It's not a guy that sits in a basement that like emails whenever he has time, right? Like this is a fully automatic system that runs at all times. And I also want to kind of make sure that you believe that it's a severity one system. Like every team on AWS that works with the border network has on call on this stuff, right? Like this is something that people get paged on 24/7 if something is wrong. And unfortunately, it goes wrong occasionally, right? Like we have hijacks, that is happening basically now. And if we wait another 5 minutes, there was another one, right? And this is things that people are looking at all times. And sometimes it's even me, right? Even I'm typically the hand-waving type of guy. I also go down in the trenches to look at this stuff. So kind of what we ended up with is that we have a multi-region distributed RPKI ecosystem, as we call it, that is servicing all generations of our border fabrics. Like we have a pretty wide, I would say, variation of our border. Like we have the super new border where we have the aggregated software and forwarding planes, and we have older, more traditional monolithic type of border architectures. We're servicing all of that through the same ecosystem. So kind of what we are doing right now. So I have 6 points here of things that are happening essentially right now that I would like to share with you guys. And the first thing is that we are moving over to delegated and distributed RPKI solutions with our own publication points. So we already have our own repos as of about 2 weeks ago, covering APAC under the APNIC parent. And we are actively looking and deploying this into essentially all regions. So ARIN, RIPE, everything comes back to us so that we can take care of kind of how the sausage is made here. And since we have been in this game for quite some time, we have been hit by basically every single outage at the RER level that you have read about. Like all of this has generated very angry AWS employees. And we have a lot of like follow-up calls with folks at RIPE, with folks at ARIN, folks at APNIC, and we're like, oh, how do we do this? How do we improve? How do we get out of this problem, right? And to some extent, the only way out of this is to take care of it yourself, right? So that is what we're doing. So what we ended up with here is something that we built on Cloud HSM, which is our own like HSM solution where we can have the CA going. We have a global and scalable rsync service, which for the one that actually know anything about rsync is not very easy. And the RDP publication is very easy since we have a very big CDN, which we can utilize to publicize RDP publication points. And I guess the thing I would like to be a call out here, like, would any of this make sense as an external service? Like, is anyone else looking into this? Would anyone like to have this? Like, please find me afterwards and let's discuss over a beer or in the bowling game. All right, next thing, BYP. I'm not sure if anyone has like cared about BYP, but I can assure that a lot of service teams at AWS has looked at this many times, and it's actually a pretty popular service. Bring your own IP is essentially you take your IPs, bring it to the cloud, and build stuff in it, right? However, if you ever looked at our process, and if you ever looked in like global route registries, you can sometimes see traces of a fairly clunky process we have. It is essentially the only process available to us, but it's not pretty. You need to register X509 certs inside routing registries and need to publicize them in whatever route registry you have available so that we can do, essentially what we're trying to do here is to tie an IP resource to an AWS user account. Today, this doesn't exist in the RPKI ecosystem, so we have to do it on the outside of it, but in like a scalable and cryptographically sensible manner. And it's not very pretty. So we have been looking a lot at IETF, kind of what's going on there and what would make sense for us here. I think we ended up with RSC as a future standard. That is essentially a drop-in replacement, what we're doing today with BOIP. So we are super looking forward to that. Hopefully we can get a good discussion on that in November on the next IETF meeting. And, you know, I can't promise that we will be the first one to implement it, but I'm sure as long as I can work at this company, I will at least fight for it, so that we can be an early adopter here. And as I said, BOIP is extremely popular. We see an increase in users basically every day, and I don't think it's going away. Point number 3, this is to work with and reach out to networks that has RPKI invalids to have them fixed. And like I have these presentations occasionally, mostly in Europe. Now we're here in the US, but this point is probably going away. Like we have done this for such a long time now. That is not a project anymore. Like it's not something we should do. We have already reached out to big networks that have invalids. They have fixed them or they haven't cared about them. And if you have a year of not caring about reaching AWS, there was probably nothing on those IP prefixes of value, right? However, those ISPs might get like a nasty surprise whenever they turn it on and turns out they can't reach anything on the internet, right? To this day, we had less than 5 tickets open in total on, you know, RPKI invalid routes of not being able to reach AWS. We have not made any exception on any of those tickets, and obviously some of these tickets has been opened by very prolific customers. But the real solution, and really the only solution that makes sense for a customer to make, is to fix the ROA. Like fix the original problem. Let's not make an exception that would probably bite someone in the very end, you know, as time goes by. Fourth, since we're here talking a little bit in a MANRS context, then we would like to continue and work on community projects such as MANRS to launch new initiatives and to foster the use of RPKI. For us, yes, as Anish said before, like MANRS is a great tool for us, a great community for us to use to be able to collaborate with others, where collaboration might be tricky or, you know, not compliant with what we want to do. However, we obviously, like a MANRS is certainly not perfect. There is things that needs to be done. And I think one of the things I would like to call out here, and I will talk about a little bit later as well, is that we would like to welcome a more stringent approach to other operators on the URPF and BCP38 filtering. Today, we have built pretty big sensor networks to figure out where does spoof actually come in from. And it turns out it comes in from a lot of places. And a lot of these places are also MANRS members that says that they are validating the source address of networks. We have data that suggests that is not the case, right? So we need like to do something better here. It could be a mistake, or it could be, you know, people not knowing what to do, or it could be technically not doable. But I think this is a place where we, and with me, I mean the MANRS community, could do better. So that's why we look forward to, for example, MANRS Plus and further work in these fields, and also a little bit less cheating from some members. Point 5. This is probably a delight to vendors in this room, and that is that we're going to bring RPKI into RFPs and RFQs as it would be a standard feature, like as if it would be like ARP or IPv4 or IPv6, which has been standard features for these type of things for a long time. So we are true strong believers in the ecosystem as a whole, and both the things that exist now and also things that are coming later, right? So today, if you want to be a transit provider to 16509, like you need to have RPKI support. Otherwise, it's a very low chance you will continue to be a transit provider or be a new transit provider. However, it should not stop there. Like equipment vendors, OOB providers, internet exchange providers, and everything in between. Like this will be just a universal rule of thumb that we support OV and ROI creation and basically everything in between, where it will be feasible and make sense. So this will be considered a must-have feature going forward, I would say. And then we're looking a bit around the corner, like what happens after this? Like what do we do tomorrow? So as we talked about, RSC, that will help us greatly in the BOIP process. It's essentially a drop-in replacement for us today to make that process actually nice for customers to use. Next thing would be ASPA verification. Like obviously I don't think I need to talk about this in this environment, but it is very easy to fool RPKI-OV as it stands today. So I think ASPA is very promising draft in CyberOps. I know there's people here in this room that is involved with this, and maybe we need a couple of more people to be involved as well and actually get this across the finish line, because I think it has stalled a little bit, and some conversations we had here over lunch suggest that that is indeed the case. However, ASPA is not perfect. It does unfortunately not solve all the problems either, and it will take us a long time together because we need vendor support, we need support from RIRs, we need support from software developers that does software for the RPK ecosystem, but we will get there eventually. Like with enough pressure, and everything bends, right? So what do we do? So BGPsec is probably a word that will make most like old school network engineers like shiver, right? And to some extent it does to me as well. However, there is a couple of good ideas there, and I think we should also remember that BGPsec was made a long time ago. Same with RPKI, you know. 5 years ago, everyone was like, oh, RPKI, that was made like 10 years ago by these crazy people. We shouldn't have any of that, right? And I guess that's what we're saying now about BGPsec as well. But, you know, the future is pretty long. It's actually infinity long, right? So, like, we have time to implement this. So there's a couple of like small initiatives around the world. I was in a panel a couple of weeks ago together with Job Snyders and a couple of other good friends where we discussed BGPsec in like a mature way. It's like, what do we need from this protocol? What can we do? What is actually achievable, right? And you know, there's a lot of networks today that are separating the control plane from the network, from the forwarding plane quite a lot, including us. And we'll probably be even more as time goes by. And when you do that, and you have a more distributed control plane, then BGPsec gets easier. So I think that in 10 years' time, I will hopefully be standing here at this stage at like NONOG 113. I guess we can have that as a goal at least, and talk about the AWS implementation of BGPsec towards at least a couple of selected peers or able networks, right? Because, you know, a lot has changed since we threw it under the bus the last time. So let's pick it up under the bus, let's look at it, and maybe throw it in again if we don't come up with a better plan. All right, next up, unsolved mysteries. And I'll put this in like these ones because they are not technically unsolved, but it's things that we need to talk about. First thing, is IRR fixable? So today, essentially anyone can pretend to be anyone and fool the IRR ecosystem. The bar is extremely low here. Really, the only thing you need is an email address, which today is very easy. You can probably buy it from us for nothing, and I'm sure that Google can provide you with an email address too, pretty easy. And then you also need an email client that can write plain text. This is hard, actually. Like, this is like, in today's world with Outlook or whatever, like writing plain text is not easy. But if you can solve that as well, then you're in a good spot to pretend to be whoever you want and basically steal whatever you want on the internet. And unfortunately, we've seen a couple of cases where this has happened multiple times in recent history as well. So it is great that you know that we have improved over the years, for example, with IRD4 semantics. I believe Job Snyders was here 3 years ago talking about that at this very stage on how to improve kind of on the IRD software side. And that's great, where we have authoritative sources like Aaron has done a pretty good job here with authenticated Aaron IRR data, and Ripe has always done a good job here. So this is great, but it doesn't really help if we also take in the garbage all the time, right? Like if you serve steak, that's great, but if you always eat it together with garbage, like it's garbage, right? Like doesn't matter if it's Wagyu steak, like it's shit. So, you know, we talk about all these important route objects in, for example, I call them AltDB and friends. These friends will be reach, it will be maybe level 3 to some extent. It could be NTT, it could be Canary. There's a whole bunch of these I would say, deprecated IRR sources. But how do we get away from that, right? Like, has anyone actually done the data here and actually looked at it? Like, do we need all of this stuff? because every single one of these RD sources is essentially 100% vector to increase the scope of how easy it is to hijack a company such as ours. So this is a little bit of like a call to action, and I really hope that someone likes to go up to this mic or come fan me afterwards and come with some really good data on this topic. Third part of unsolved mysteries, right? So that would go back to BCP38 or source address validation or EuroPF, whatever you want to call it. So today, spoofed volumetric attacks using broken UDP services, or maybe not even broken, like it's just using UDP services. It's still, I would say, the most common vector for launching large-scale DDoS attacks. Basically, everyone in this room probably knows this. Our triangulation data suggests that the most common and effective way to do this is to originate the spoofed attack over a transit link from a large ISP. Given our peering surface, which stretches 10,000 peers or whatever it is, like we have links towards most networks in the world, we have a fairly easy way to add 1 and 2. We see 2 links, we see someone pretending to be AWS over here, and we see the same traffic coming in over here. We have a fairly good idea of who the bad players are. And we obviously understand that it can be hard to solve this, especially if you're a big tier 1 carrier. How do you solve this in a sensible way? Today, it's really hard. Essentially, the only way today is the feasible path with fail filters, which is only available in certain vendors. Or traditional ACLs, which is technically available everywhere, but can be very hard to maintain, especially if you build it on IR filters, which we already learned is shit data, right? So this is, how do we come back from here? How can we scale up EuroPF where it makes sense? Because we get the most impact if we get it from large ISPs instead of pushing this to the stubs, where it's easy implementable, but perhaps not very effective. Third and last part, which is RPKI and RTBH, or ingress TE, whatever you want to call it, right? I guess this is essentially 2 different things, but it's like we probably need 2 solutions to the same problem here. So today, it is really hard to do RPKI, origin validation, and allow RTBH at the same time. Essentially, what we see today is that the origin validation part is just skipped if RTBH is offered, right? And it's not very good, like to register like ROAS that allow up to /32, because then you're essentially, then OV is basically not really, it doesn't work for you, right? So there's really not a good solution here. One of the things I've been looking at least is what we call today RPKI DOA. One of the authors is here actually back in the audience, I see. And it's something that, we're keeping an eye out to see if this could be a potential solution to the problem we have. Because we actually use RTBH occasionally. So we would like to have that option for, primary big tier 1 carriers to accept RTBH black holes from us while doing OV at the same time. Because today that is not really doable. Today, I guess this is a somewhat controversial topic, or at least something that I think we get the most questions about, is that we do produce ROAs today with pretty permissive max length. And this is to be able to do ingress TE for us, so traffic engineering on the ingress side. Like we have load balancer which automatically cuts prefixes in half and sends them out over 2 links if we detect that someone is blasting us too hard. So would we ever reach a place in time where we could get like a ROA convergence time to be less than 10 minutes? Like in general at least, because that would be kind of where we are today with our ingress TE mechanics, and where we would probably like to be in the future if we kind of change this, right? Or if there's any other solution to this problem, right? Because we need to have the possibility to maintain our like /14, /12, /16 announcements, while still have the possibility to split a couple of them up to do ingress TE. Because I don't think that anyone in this room would be very happy if we deaggregate all of our space. Because today it's roughly 2.8% of the V4 internet, and giving that as /24s, which is, a pretty good solution, right, in general, but not at our scale. I think that we will be cooking a lot of routers out there, and I think that's very good. That is kind of what I had, and I'm actually at 2nd, which I'm pretty proud of. So I'm happy to take questions on this topic. Or yeah, you can also find me, on the RPKI Discord, or on IRC?
Hey, Warren Kumari, Google.
Hi.
And also IETF Operations AD. So you mentioned the IETF CyberOps RPKI RSC draft and that you hoped it would come out soon. It's actually in the RFC editor queue, so no need to discuss it in London, and it should be out soon.
Thank you very much. We're looking forward to that.
There's a question from a remote attendee. Matthew Pitak asks, for your term number 4, are you proposing to name and shame ISPs who claim compliance with MANRS Action 2 but really aren't, or do you have some different proposal for actually giving MANRS some real teeth?
Yeah, I mean, I don't think that we are generally in the business of name and shaming, at least not in an official setting. But in an unofficial setting, I think that's a very interesting idea. And how we have been addressing it this like right now is that we've been talking directly with ISPs at hand. It's like, hey guys, we actually see you do this, and you know, if you want to keep those peering sessions alive, right? Like, let's get some stuff fixed, right? If we believe that it is even fixable. I think that is kind of the answer to that question. We have a mic over there.
Ben Madison from Workalign again. As Warren said, the RSC document is pretty much ready to come out of the sausage machine. If it's something that's of interest to people, then the most helpful thing that people can do at this stage is speak to their RIR and ask them to crack on with implementation, because the draft on its own without a implementation at the RIRs is of questionable value.
I agree.
Thank you, Frederick.
All right, thank you very much.
So our next talk is entitled Building Reliable RPKI Infrastructure for Large-Scale Networks and Protecting Networks Against DDoS. Samesh Chatramota is a Principal Software Engineering Manager in the Microsoft Global Networking team. He's responsible for managing the Microsoft Edge Network, and he has been leading the Microsoft Edge Networking team for more than 3 years and has more than 15 years of experience building various software-defined network controllers for cloud-scale networks. With that, we'd like to welcome Samesh.
Hi, I'm Samesh. I'm the engineering manager for the Edge team. Edge, not the browser, the Edge, the network which connects to the rest of the internet. I joined the Edge team about 5 years ago and then started leading this team, 3 years ago. And I don't come from the networking background, so there are a lot of network engineers in my team hate me for, trying to simplify the network. And, it's been the challenge which we've been up to for a long time, how to make the network scale for the cloud. And I'm going to talk about how at Microsoft we have solved some of these challenges about routing and traffic security. Okay, so this is the slide which everybody is presenting, so I'm also going to present this slide. It's one of the largest network in the world. Like, we have 60 plus Azure regions. We have our own dark fiber connecting most of our Azure regions today. Operating 190 edge network POPs, 200 express out partners, and numbers are there for you to see on the screen. But it's really that scale of this network becomes much bigger when you talk about the kind of the routing database we have. Every routers we have in the network is producing large amount of routing database for us to validate. And when I joined this team, I was given a task to, improve the routing hijack. And, we had a couple of incidents which were pretty impactful at Microsoft, related to Microsoft's routes getting hijacked on the internet. And, my journey in 2018 started to build a system we call it as radar, which stands for route anomaly detection and remediation. So we took a different approach, collecting the data from the router, and whenever somebody will hijack Microsoft route, we will launch our own route to get the traffic back. And this is the advantage you get with the large scale network, because we have so many peers. With the very first announcement itself, we'll take the entire traffic back to Microsoft. And we built that system, then we kind of looked at it and say, okay, we can use this thing to also detect the internet routes at Microsoft. And we put some relationships and the machine learning, actually it is the system which is kind of learning on its own of how the network relationships are evolving, and then still giving us the large amount of right data on how to filter the internet route at Microsoft. But then as you can see, we needed something to be proactive. Radar was reactive. Even though our mitigation time was 2 minutes, we will get the data, the BGP propagates very fast, we get the data very fast, but still we needed something to do proactive. And in 2020, we created ROAS for most of the Microsoft routes, as you can see on the top of the screen. But it took us some time to also get the ROA system up to date, because we had to manage routes across multiple registries, and with multiple registries everybody has different APIs and different kind of renewal policy. And I actually did talk about it in one of the MANRS blog, that hey, how each and every registries can come together to solve the common problem of managing the ROAS. And then after 2020, we actually did not see a hijack which is impactful. So touch wood, we've been there with the RPKI, and this is one of the things which I give it back to the MANRS community. The RPKI implementation, RPKI signing of our routes has really protected the Microsoft network very well on the internet. And we then took it saying that, hey, we will also implement RPKI filtering inside the Microsoft network. And again, we started building the RPKI filtering on our network, but then we ran into multiple issues, both with the vendors as well as with the IRRs, and all the common problems which others talked about, we ran into the same issues building the RPKI filtering system. But finally, in 2022, this year itself, we have implemented RPKI filtering across our network. So I talk about building the reliable RPKI infrastructure system. So I'll talk about the challenges. As we started deploying RPKI filtering, we ran into issues. One of them, the common one, is the BGP route propagation is faster than the ROA propagation. People will sign their routes and then straight away announce to the BGP. The BGP still thinks it's invalid. ROA hasn't come to the system yet. How do you do this thing? People change AS numbers on the BGP routes. Similar issues, they commonly happen, and we have seen the amount of churn which was happening on our routers when we started putting just on a pilot router. We just put it on a pilot router, believe me, it crashed. So yeah, it was pretty crazy to see the amount of data coming in from the router and then what was going on. So we have to look at it of how to make it really work for our scale of our network. Microsoft network is pretty large network. The link on the presentation is about what we want, this problem which we have solved at Microsoft. IRRs can solve this thing. IRRs can solve this problem to make sure that when people are managing ROAS, they do not commit simple mistakes. So what we did inside the Microsoft, of course, we took the control plane and data plane together. With the radar, we know the routing data plane inside the router, and we get the data from all the registries. Then we filter it to make sure that we are not missing any data. We perform the BVT or basic validation test on those ones. Then we run some extensive tests before we give this feed to the router. And once we give the feed to the routers are pretty stable, that they can perform the ROA validation. But this has really helped us to protect against large outages. Remember, Internet was born 30 years ago, and it has become, the BGP has become stable in 30 years. RPKI is a new system. It will go through its own challenges. The systems has to get mature and more stable. And this is where we think that as we look at the future of the RPKI and ROA validation, we think that the IRRs can put the data plane data, merge with the control plane, and really improve the ROA management. You will never have a BGP propagation slower than the ROA. ROAs will take time, as somebody will manage, like, it's a protocol which is meant to take time. So that's why it is very important that the IRRs can take the first step on solving some of this problem. They have the data on the routing data plane. Anyways, shifting the gear a little bit more, and I think we're going to run out of time. This is one of the top challenges which we are facing as of now. I think we think that with MANRS and with the community coming together on the RPKI, routing data is protected to the large extent. However, the traffic is the next challenge. The data on the screen is from the MANRS. We see a lot of DDoS attacks. Lot of DDoS attacks coming in, which we think is caused by spoofing. And it is very easy to do this kind of attacks. However, it is also very easy to protect against this kind of attacks. During the COVID time frame, we saw a sudden increase in the DDoS coming in, and all of us had to struggle to get the capacity. We are all struggling to get the capacity, and we were deploying capacity as we speak, but we are also dealing with the DDoS. We took some hard measures to protect the network against the DDoS attacks. But as I said, Frederick mentioned about the BCP38 or URPF. We have actually started now deploying URPF in our network, because we think that in order to protect the internet security relies on us taking the next level measure of implementing URPF. Just like RPKI, we are deploying this in what if mode. But as we go, and we think within a year or two time frame, this is my first NANOG, and this is my newcomer batch. So I'll be here in next 2-3 years and talking about this, that we have implemented inside the Microsoft network a URPF, and really we have the hardware vendors providing different set of features, in the feasible mode and with the fail fast filters, so on and so forth. But really it is the way to protect the spoofing, which will be one of the biggest challenges internet has to solve. And not only we have to solve, but we think the community needs to solve. And my sole reason for coming here to the stage is to basically ask the community to look at this and say that yes, we have to protect the spoofing on the network. The systems of traffic engineering has to evolve to adhere to spoofing, and we expect that we will deploy the URPF in the extensible or the feasible mode, which allows you to engineer the traffic inside the Microsoft network. However, it cannot be that your routing plane data and your traffic data does not match. We will make sure that you have the routing plane data always matches with the traffic data. It might not be the best path, we control the policy in our network. However, it has to have the data. Without that, we don't think so that the network which is facing its next challenge, 5 years ago, it was the graph I showed you in the second slide, was every day it's a hijack or a few things going on, and some are intentional, some are done through the mistakes, and most of them, after the claim, they came to be the mistake. But we have overcome that problem. We think that the internet community together has made a tremendous progress in solving the BGP security problem or a route hijack problem. But this one is the next in front of us. And I think if we can solve this within the community of how the spoofing should be prevented, simply many networks can deploy outbound ACL policy. That's an easy one to do it. But even if you're getting a traffic from someone, and that goes back to the large transit providers or the large networks, if you're peering with the large set of networks, your customer routes, you should be able to filter it and make sure that the traffic is only coming from them. Because it's the next vector which people are exploiting on the internet. With that, I want to say thank you for being the part of the NANOC this year, and then thank you on behalf of Microsoft. We really think that the internet has made a lot of progress in terms of improving the internet security, which I'm really passionate about. My goal is to make internet better every day, and it's how we think that the trust over the years have eroded on the internet. It has to come back, and it has to start from this set of people who can take on this thing. Lastly, I'll conclude with the MANRS. Please, MANRS is the forum which we all come together and we really take part in the community to strengthen the internet security. And on behalf of MANRS, I would like all of you to join the MANRS community and adhere to the MANRS principle. Thank you so much.
Q&A.
Oh yeah, please.
Hi, Tony Tauber, Comcast. Thanks to you and all the presenters for sharing the excellent content. About the radar thing that you had the sanity check for RPKI information, how many, if you can say, how many cases were there where you actually had, it detected something that would have caused some kind of outage?
I think we had in the last 2 months we had couple of incidents, because I don't have the data, I haven't looked at it for the past. In last 2 months we had couple of incidents where the feed just went away. And I think there was a famous incident back in 2021, if I'm not mistaken, from the TWNIC about a lot of routes becoming invalid. I think that was protected by the system. Fortunately, it did not install those ROAS on the router, and that was the really issue which we saw, which kind of made us to think, saying, no, it cannot just be that whatever is sent to us and you have to filter it out, make sure that things are correct. You have to understand that this is a new protocol, so it will take some time to mature. So that's why we had couple of incidents where we saw the basic validation test failing. Of course, our basic validation test includes our own signed routes coming back to us.
Thanks.
Hi, Danny McPherson, VeriSign. Just a quick question on URPF. Are you doing strict mode or loose mode for that?
We cannot do loose mode. I think the loose mode defeats the purpose for us, especially the way the architecture is set up right now. And I'll be, honest with you. But we are doing extensible, which is little bit more than, it's between the strict and the loose. It's in between where we want, it will not be the fib, it will be dictated by the rib, but rib on the interface, not on the router.
Okay, thank you.
That's it.
Thank you very much, Sumesh.